Now, a powerful eruption caught on camera at Yellowstone National Park that sent debris raining down on visitors.
Yellowstone National Park, a true wonder of nature, is keeping a powerful secret beneath its surface. Recently, its officials reported that hundreds of earthquakes have hit the area, and scientists are watching closely. Could this be the warning sign of a massive volcanic eruption, as experts have predicted? Or is something even more mysterious happening beneath the bubbling geysers? Join us on this epic journey as we uncover the recent report of hundreds of earthquakes that hit Yellowstone National Park. History of Yellowstone earthquake. Yellowstone National Park experiences a constant rumble beneath its surface, with thousands of tiny earthquakes shaking the ground each year. However, most of these quakes are so small that people can't even feel them. The majority, around 2/3, occur in a zone between Hebgen Lake and the Yellowstone caldera, a hotbed for seismic activity due to a buried fracture left behind by a massive volcanic eruption over 2 million years ago. While most of these earthquakes go unnoticed, there have been a few that left a significant mark on history. 6 major quakes, with magnitudes of 6 or higher, have been recorded, including the powerful 7.2 magnitude Hebgen Lake earthquake in 1959. This quake, just outside Yellowstone's northwestern border, triggered a massive landslide. The landslide caused part of the dam on Hebgen Lake to collapse, and as the debris flowed downstream, it blocked the river and formed a new lake, which is now known as Earthquake Lake. Tragically, 28 people lost their lives, and the damage was widespread. The quake also shook up the park itself, causing geysers to erupt more violently, large cracks in the ground to appear, and some normally clear hot springs to become muddy as the earth released steam. Scientists believe that the stress from the 1959 quake still influences the seismic activity in the northwest section of the park today. One such event was a magnitude 6.1 earthquake in 1975, but luckily, this time, the damage was minor. In 1985, Yellowstone experienced what is known as an earthquake swarm, a flurry of 3,000 minor tremors over 3 months. This swarm was linked to slight changes in the ground level of the Yellowstone caldera. Earthquake swarms like this aren't uncommon in the area, with 70 recorded between 1983 and 2008. For instance, in December 2008, more than 250 quakes shook the ground beneath Yellowstone Lake over 4 days, the strongest being a magnitude of 3.9. Another swarm followed in January 2010, with over 250 quakes detected in just 2 days. The park's seismic activity is closely monitored, with real-time reports from the U.S. Geological Survey's Earthquake Hazards Program. The quakes are frequent, but Yellowstone's most recent significant shake came on March 30th, 2014, when a 4.8 magnitude earthquake struck near the Norris geyser basin. It was the biggest earthquake to hit the park since 1980, though, fortunately, it caused no damage. Now, let's explore some valuable natural resources in the park. Yellowstone geothermal treasures. Yellowstone National Park is a huge area, covering 34,684 square miles. It's a land filled with lakes, canyons, rivers, and mountains. One of its most notable features is Yellowstone Lake, which is one of the largest high-elevation lakes in North America. This lake sits atop the Yellowstone caldera, the continent's largest supervolcano. Yellowstone's importance goes beyond its geological features. It's the heart of the greater Yellowstone ecosystem, one of the last almost untouched ecosystems in the northern temperate zone of Earth. This vast wilderness is home to a wide variety of plants and animals, from tall forests to elusive wildlife. Because of its ecological significance, Yellowstone was named a UNESCO World Heritage Site in 1987. But Yellowstone isn't just about nature. The park has a rich human history, with hundreds of buildings that are architecturally and historically important. Researchers have studied over 1,000 indigenous archaeological sites within the park, revealing the ancient civilizations that once flourished there. Beneath Yellowstone's calm surface lies a diverse community of animals. There are hundreds of species of mammals, birds, fish, reptiles, and amphibians, some of which are endangered. The vast forests and grasslands support unique plants, adding to the park's ecological diversity. Yellowstone is known as the largest and most famous megafauna location in the contiguous United States, home to iconic species like mountain bears, cougars, wolves, and free-ranging herds of bison and elk. The Yellowstone Park bison herd is especially notable as the oldest and largest public bison herd in the country. Nature's power is clear in Yellowstone, especially through the forest fires that happen each year, reshaping the landscape. The terrible fires of 1988 burned nearly one-third of the park, leaving a lasting impact on its terrain. Despite these challenges, Yellowstone remains a paradise for outdoor enthusiasts, offering a wide range of activities year-round. Visitors can hike, camp, boat, and fish, immersing themselves in the park's beauty and peace. However, underneath the park's surface, the Earth's hot core creates a variety of warm spots. These natural wonders are spread throughout the park, showing a beautiful collection of geyser basins, hot springs, mud pots, and steam vents. Yellowstone is a hotspot for geothermal activity, with around 10,000 thermal features in total. A study in 2011 counted 1,283 geysers in the park, with 465 of them erupting each year on average. These geysers are found across 9 main basins, and even some smaller areas have their own geysers. While famous geysers like Old Faithful get most of the attention, many of Yellowstone's geysers are smaller but just as interesting, often shooting water only a few feet high. The park's geothermal activity is powered by its ancient and active volcanic crater. When underground water meets volcanic heat, it creates a show of steam and bubbling pools, leaving behind minerals like geyserite and travertine. Yellowstone's geothermal marvels go beyond its well-known geysers. The park's landscape is filled with different thermal features, each with its charm. From the colorful pools of the Grand Prismatic Spring to the boiling pots of the Norris geyser basin, visitors are treated to a show of natural beauty. Beneath this surface, beauty lies a complex ecosystem shaped by heat and water. Microorganisms thrive in the extreme conditions of Yellowstone's thermal pools, forming vibrant mats of bacteria and algae. These tiny life forms not only add to the park's stunning visuals, but also play a key role in maintaining its ecological balance. The geothermal features of Yellowstone are not randomly placed. They are located where the Earth's fiery energy meets surface conditions. Geyser basins, where rainwater and snowmelt seep into the ground and meet the intense heat of Yellowstone's hotspots, are prime locations for these wonders. Located in flat-bottomed valleys between ancient lava flows and glacial deposits, these basins are stages for spectacular eruptions of geysers, hot springs, and steam vents. But the geothermal wonders aren't confined to these large basins. Smaller thermal areas are scattered across the landscape, marking fault lines, circular fracture zones around the caldera, and slopes where extra groundwater collects. Next, we'll look at the physical structure, the materials that make it up, like rocks and minerals, and the processes that have shaped it over time. Geology of Yellowstone. At Yellowstone's high elevation, the average boiling temperature in the geyser basins is about 199 degrees Fahrenheit. When the pressure builds up and conditions are perfect, geysers like Steamboat Geyser erupt, sending boiling water and steam up to 390 feet into the air. However, despite the scorching temperatures inside the geysers, the water cools down as it flies through the air, keeping spectators and nearby boardwalks safe. Yellowstone's geothermal wonders are fascinating but also risky. The extremely hot water can be dangerous if you get too close, so authorities enforce strict safety measures. Visitors are urged to stay on designated boardwalks and trails to respect these natural boundaries. Sadly, past incidents have shown the dangers hidden beneath Yellowstone's peaceful surface, with several deaths caused by falls into hot springs. Artifacts found at Mammoth Hot Springs and other thermal areas show a deep connection between ancient peoples and the Earth's fiery heart. Some evidence suggests that early inhabitants used the hot water from these geothermal features for bathing and cooking, utilizing nature's power for their daily needs. In the 19th century, a new era of exploration began, bringing tales of wonder and mystery. Father Pierre-Jean Desmay, upon seeing the awe-inspiring geysers, recounted that the native peoples believed these geysers were the battlegrounds of infernal spirits locked in eternal combat. Even the famed Lewis and Clark expedition, traveling north of Yellowstone in 1806, encountered locals who avoided the caldera's depths, fearing the thunderous roars from within and the wrath of the spirits. Among the brave explorers was John Coulter, a member of the Lewis and Clark expedition, who ventured alone into the heart of Yellowstone. His accounts of the geothermal features he encountered painted a picture of a mesmerizing and terrifying landscape, where hot springs bubbled with sulfur and steam rose like smoke from industrial chimneys. Trapper Jim Bridger famously described Yellowstone as the place where hell bubbled up. His words capture the essence of Yellowstone's geothermal wonders. Deep below the solid volcanic rock and sediment lies a superheated brine, a salty mixture simmering at over 400 Fahrenheit. This brine, under immense pressure, is the lifeblood of the geothermal wonders that captivate visitors worldwide. As it shakes and boils underground, the heat seeps into the surrounding rock, transferring its fiery energy upwards through the fractured and porous network beneath the Yellowstone Plateau. This heat warms a layer of fresh groundwater, mingling in a geological alchemy. Along the way, silica, a steadfast mineral of the Earth's crust, dissolves and redeposits, forming a network of pressure-sealed conduits. This journey spans millennia. When the superheated water reaches the surface, it unleashes its pent-up fury in a spectacle of steam and splendor. Geyserite and sinter, the silent witnesses to this ancient dance, bear truth to the ceaseless power of nature. The Norris Geyser Basin, in particular, is a hot pot bubbling with geothermal activity. Located in Yellowstone National Park, it's known as the most active geyser basin. It's a hotspot where boiling water shoots from the ground, creating a spectacle of steam and splashes. This basin sits near the northwest corner of the Yellowstone caldera, a giant volcanic crater close to Norris Junction. What makes this place special is that it sits where three major faults meet: the Norris Mammoth Corridor, the Hebgen Lake Fault, and the Ring Fracture Zone, from which the Yellowstone caldera was born 640,000 years ago. These faults are like nerve centers, making the basin super hot and active. Occasionally, the Norris Geyser Basin experiences shakeups, acting wild for a few weeks. During these episodes, water levels fluctuate, temperatures swing, colors change, and geysers erupt in new ways. For instance, in 1985, Porkchop Geyser kept shooting out steam and water without stopping. In 1989, it got blocked with silica, causing a big explosion that threw rocks as far as 200 feet away. In 2003, a park ranger saw Porkchop Geyser bubbling crazily again, something it hadn't done since 1991. The activity spiked later that year, making parts of the back basin so hot they had to be closed off to keep people safe. In 2004, they even had to change the boardwalk route to go around the danger zone and behind Porkchop Geyser for safety. You might be curious about what's causing all this excitement at the Norris Geyser Basin. This area is like a giant pressure cooker because it sits at the intersection of three major geological faults. When these faults intersect, they create intense pressure, much like a lid on a boiling pot. Adding to the drama, there's a ring fracture zone from an ancient volcanic eruption, which is like throwing fuel on the fire. The hot water and steam trapped underground are always trying to escape, and sometimes they do so in spectacular eruptions. Beneath the surface, there's a lot of heat. This heat causes steam to build up pressure. When the pressure becomes too much, an eruption occurs. The Norris Geyser Basin, sitting right on top of all this geothermal activity, becomes a hot spot for these eruptions. But it's not just the heat causing all the commotion. The rocks below play a significant role too. Some rocks are rich in minerals like silica. As hot water flows through these rocks, it picks up silica, which can block the vents of geysers and hot springs, similar to how gunk clogs a drain. When this happens, pressure builds up even more, leading to powerful explosions like the one at Porkchop Geyser. Moving further, let's examine the movement and vibrations within the Earth's crust, typically caused by the shifting of tectonic plates, volcanic eruptions, or other geological processes. Yellowstone's seismic activities. Yellowstone experiences between 1,500 and 2,500 earthquakes annually, based on data from the past 3 decades. However, Yellowstone's seismic activity is unpredictable. In 2017, there were 3,427 earthquakes, while in 2011, there were only 78. The pieces, or tectonic plates, are constantly moving and shifting against each other. When stress builds up along the edges of these plates, earthquakes occur. Yellowstone sits on one of these hotspots where the Earth's crust is under immense pressure from both plate movements and volcanic activity beneath the surface. When this pressure becomes too much, the rocks along faults give way, releasing energy in the form of seismic waves. These waves travel through the Earth like ripples in a pond, causing the ground to shake. Once these waves reach the surface, they can be felt by anyone nearby. Surface waves are especially disruptive, causing the ground to roll like ocean waves, crack open, or shift like a sliding puzzle. This movement can wreak havoc on structures, which are typically designed to withstand horizontal motion, not the chaotic shaking of an earthquake. In Yellowstone, earthquakes aren't just random rumbles. They play a crucial role in the park's hydrothermal activity. Think of it like a plumbing system. Without these occasional shakes, the small cracks and channels that feed hot water to geysers and hot springs could become blocked with minerals over time. Earthquakes help keep these channels clear, ensuring the geysers and hot springs remain active. Some earthquakes can significantly impact Yellowstone's famous features. For instance, the 1959 Hebgen Lake earthquake, a massive 7.3 magnitude event, and the 1983 Bora Peak earthquake measuring 6.9, caused noticeable changes in features like Old Faithful Geyser. These events show how closely linked Yellowstone's geology and seismic activity are. Earthquakes also help scientists understand Yellowstone's underground world. As seismic waves travel through solid rock and molten magma at different speeds, scientists can analyze these waves to map out the subsurface geology. It's like using sonar to navigate the ocean, but instead, they're exploring Yellowstone's magma chamber and caldera. An extensive monitoring system is in place to constantly watch for seismic activity, helping to reveal the secrets beneath Yellowstone's surface. On June 16, 2017, around 6:48 p.m., the ground shook with the biggest earthquake of the year, measuring a magnitude of 4.36. It happened about 9 miles northwest of West Yellowstone, Montana. But this quake wasn't alone. It was part of a bigger seismic event called the Maple Creek Swarm, which started on June 12, 2017, and lasted until October. During those months, over 2,475 earthquakes rocked the area, centered 6 miles north of West Yellowstone, spreading to the western edge of the park. It's like Yellowstone was hosting its own underground fireworks show. Now, back in 1985, the park experienced its biggest swarm ever, with over 3,000 earthquakes in just 3 months. Then, in 2009 and 2010, there were more swarms near Lake Village and between Old Faithful and West Yellowstone. Scientists think these swarms happen because of pressure shifting and changing within the Earth's crust, driven by the movement of fluids underground. It's like the Earth itself is dancing to the rhythm of nature's beat. But predicting when and where these swarms will happen is still a mystery scientists are trying to solve. Even though Yellowstone has been monitored since the early 1970s, we base our understanding of normal seismic activity on data from 1995 onwards. That's when the monitoring network got a major upgrade, with more stations and better technology, allowing us to detect smaller earthquakes that were always there but went unnoticed before. Well, they usually go unnoticed, but once they hit 4.0 or higher, they can start causing some damage. And while earthquakes above magnitude 6 are rare in Yellowstone, they've happened in the past. An earthquake struck near Hebgen Lake, triggering a massive wall of water that surged over Hebgen Dam and altered the landscape forever. But here's the thing. Yellowstone's seismic and volcanic activities are often unrelated. While earthquakes typically happen along the edges of tectonic plates, Yellowstone's caldera is a hotspot, bubbling deep underground. But when water gets into the mix, things can start shaking. Water interacting with faults can ramp up seismic activity, creating those mesmerizing earthquake swarms we've seen. If earthquakes were to escalate further at Yellowstone, it could have implications for infrastructure, essential services, and the economy of the surrounding areas. Now, let's delve into what scientists are doing to monitor this seismic activity. Yellowstone Volcano Observatory. Scientists are keeping a close eye on the Yellowstone volcano, watching for any signs that it might erupt in the future. To do this, teams of experts are constantly monitoring its activity and looking for signs like earthquakes or changes in the ground. At the heart of this work is the Yellowstone Volcano Observatory, which is the main hub for tracking and studying the volcano. This observatory is a joint project led by the United States Geological Survey, the University of Utah, and the National Park Service. Together, these organizations bring in experts from different fields, like geophysics, geochemistry, and geology. Their mission is to keep the public and emergency teams informed and safe by providing timely warnings in case of an emergency. To monitor Yellowstone, the observatory uses a wide range of tools, including seismometers, which measure earthquakes, and GPS receivers, which track ground movements. These instruments are key to detecting small shifts in the Earth's crust, which could signal that the volcano is waking up. Scientists also pay close attention to Yellowstone's famous geysers, hot springs, and fumaroles, steam vents, since any unusual changes in these features can be a sign that volcanic activity is ramping up. While the observatory has a strong monitoring system in place, the team isn't resting on its accomplishments. However, there are still challenges ahead. Maintaining and expanding monitoring networks in Yellowstone's remote and rugged terrain is a tough job for scientists. They have to travel over rough roads and through desert-like landscapes to set up observatories. Every step in this process can be tricky if not done properly. The remote location and harsh weather conditions of Yellowstone add to the difficulty. Scientists often need special vehicles like helicopters and snowmobiles to reach their monitoring sites. They face extreme temperatures, strong winds, heavy snowfall, and unpredictable weather. These conditions can be dangerous for both the equipment and the people working in these areas. In winter, deep snow and ice can bury monitoring stations, while summer storms can damage sensitive instruments. This means that scientists frequently need to perform maintenance and repairs. Despite the project's importance, the observatory is struggling with limited resources and tight budgets. Buying, setting up, and maintaining equipment is costly, forcing researchers to stretch their finances to the limit. This often results in gaps in monitoring coverage, leaving some crucial areas unprotected. To tackle these challenges, scientists are exploring new technologies and innovative solutions. For instance, they are developing automated systems that can handle extreme weather and reduce the need for manual upkeep. They are also working on combining data from various sources to improve the accuracy of their predictions and warnings. Another important goal is to enhance how scientists, policymakers, and the public communicate and work together. This means creating clear and simple explanations for complex scientific ideas and sharing timely and precise information with everyone. In the future, scientists aim to develop more advanced systems that can detect even small changes in the Yellowstone volcanic system. They also hope to gain a better understanding of what drives volcanic activity, which will help them make more accurate predictions and warnings. To achieve this, scientists are exploring new technologies. For example, they are considering using automated drones with thermal cameras to detect heat from volcanic activity. They are also looking into artificial intelligence to analyze data in real time, which can help spot patterns and unusual events. Additionally, they are working on new sensors that can handle extreme weather and provide more accurate measurements. Improving communication and collaboration between different agencies and organizations will also be crucial, as it will enable a faster and more effective response to volcanic threats. One of the park's famous residents, the bison, has a really interesting link with the geological activity happening under Yellowstone Lake. Before earthquakes hit, bison herds often show unusual signs like being restless and moving away from places where there's more geological activity. These changes in their behavior might be clues that a volcanic eruption could be coming. This gives scientists important hints about how animals' actions and geological events are connected. By observing bison herds and their movements, scientists can learn more about what causes volcanic eruptions and earthquakes. Including wildlife observations and volcano monitoring could help predict and prepare for these natural events. Combining the knowledge of scientists with nature experts can help create strategies to protect both people and animals from possible dangers. Recent earthquakes in Yellowstone can be alarming and damaging, but it's reassuring to know that efforts are underway to spot and prepare for future seismic events. Now, let's uncover the link between animal behavior and recent seismic activities. Now it's time for today's subscriber pick. Yellowstone National Park had always been a place of beauty, but one quiet morning, the ground began to shake. Trees swayed, animals fled, and the earth roared like never before. An earthquake, never seen before, hit Yellowstone with terrifying force that made officials release a report. Geysers exploded with boiling water, and cracks spread across the land. The park's rangers scrambled to help visitors and protect the wildlife. As the dust settled, the officials realized something big had changed. Yellowstone wasn't just a beautiful park, it was sitting on a ticking time bomb. The giant volcano beneath it was showing signs of waking up. People across the country held their breath, wondering what might happen next. The world watched Yellowstone, waiting for its next move. The future of the park, and perhaps the planet, seemed uncertain. Would the volcano sleep again, or was this the beginning of something much worse? Let us know your answer in the comments section. Yellowstone's wildlife. The park's landscapes vary from thick green forests to wide open meadows, and from hot bubbling geysers to icy flowing rivers. These diverse environments offer a safe home to many different plants and animals. However, something unusual has been happening lately. Visitors have been having odd experiences with wildlife, especially with bison. Recently, despite repeated warnings and near misses, a woman was injured by a bison. Another tragic event occurred when a woman was found dead on the Buttermilk Trail, about 8 miles from West Yellowstone. Investigators discovered mountain bear tracks at the scene, suggesting that she may have had a fatal encounter with a bear. To protect both people and bears, the area has been closed while the investigation is still ongoing. The debate is still ongoing about whether there's a link between wildlife behavior and recent seismic activities. Some experts think that animals might be sensing things we can't because they've lived in harmony with the land for thousands of years. The idea that animals can detect earthquakes before humans isn't new. There are recorded instances where animals like dogs barking excessively or cats hiding have shown unusual behavior before earthquakes. In Yellowstone, this connection might be even deeper. The park's geothermal features and seismic activities are part of its natural landscape, and wildlife has adapted to these conditions over millennia. For example, bison have a strong bond with the land. They use the park's warm geothermal areas in winter, and their migration patterns are influenced by the region's geological features. The recent changes in animal behavior might be related to shifts in underground magma chambers or other vibrations and chemical changes in the environment that humans can't perceive. Scientists are currently investigating these possibilities, looking at how animal behavior might relate to seismic data and changes in river flow. The eruption of geysers and the rumble of earthquakes are closely linked in ways we're just starting to understand. In areas with so much geological activity, like Yellowstone, the risk of earthquakes or volcanic eruptions is a serious concern. Authorities are working hard to grasp these risks, monitor them, and find ways to reduce them. The new monitoring plan for the Yellowstone volcano, created by the Yellowstone Volcano Observatory-YVO- and its partners, aims to improve how we watch and assess hazards in the region. This plan features detailed descriptions of both current and future monitoring systems, focusing on 2 main areas: backbone monitoring and hydrothermal monitoring. Backbone monitoring involves the existing network of tools spread across the Yellowstone Plateau. This network includes seismometers, GPS stations, and other instruments that keep an eye on seismic activity, ground movements, and other geological changes. These tools are strategically placed throughout the park to provide real-time data about what's happening below the surface. Over the next 10 years, this system will be upgraded to enhance its effectiveness. Hydrothermal monitoring is a new addition to the plan. It will track activity in Yellowstone's thermal areas and geyser basins by measuring temperature, pressure, water chemistry, and other factors. This monitoring will help us understand how the hydrothermal system behaves and detect any unusual changes that might indicate a potential geological event. The University of Wyoming, along with other scientific organizations like the U.S. Geological Survey and the National Park Service, is actively involved in this effort. Their work shows the importance of understanding and managing the geological risks in the Yellowstone Plateau region. What are your thoughts on the shocking report of hundreds of earthquakes by Yellowstone officials in the area? Let us know your opinion in the comments section.